Hi everyone, welcome to mosgyan. So in today's video, we have been given one question where one MOS M1 is given to us and three capacitors are connected across its gate and source terminal. Across source and ground, two capacitors are connected which is denoted as CL and CS, whereas one capacitor is connected between gate and source terminal of this MOS M1 which is represented by C. And in this question, it has asked to find out the input impedance looking from here for this circuit. So we know whenever we have to find out input impedance for any given circuit, the one standard approach of finding input impedance is that we can connect one test voltage which we can denote by V test, and we assume the current going because of this V test voltage is IT, which is flowing in this MOS. Right. When we have to find out input impedance, we can find out the value of current IT, and if we divide V test divided by I test, we will get the input impedance value which is asked in this question. So now this question is all about finding the value of this current IT. So if you see the circuit, if the current IT starts flow from here, there won't be any current going inside the gate terminal because input impedance of gate is infinite. So whatever current IT will flow, that will start flowing from here, that will traverse from this path, from this capacitor C, whole current will flow, and then entire current will go in these two branches. Now these CL and CS are in parallel, so instead of this, we can have one common capacitor whose value would be equal to CL plus CS. So now we have removed that parallel capacitance. Instead of that, we have this load capacitance whose value is equal to CL plus CS. Now this IT current will flow from this path. Along with that, there would be some current because of this MOS M1 also. Let's represent that current with ID current. So the value of ID current would be equal to Gm of this MOS into VGS voltage. Right. Now let's call this node as VS node. So we can write the equation here for ID current, that would be equal to Gm into VGS, right? Now VG voltage we know that is VT here. We don't know the source voltage, but we can find out the source voltage easily because the voltage across this capacitance would be equal to Vs only. So if I have to write Vs, I can write it as 1 upon S into this capacitance whose value would be CL plus CS into current. Current would be I test plus I drain current, right? I test plus I drain. So this would be the value of VS voltage, which is source potential for MOS M1. Now instead of ID, I can replace this value here in this equation. So it would be like 1 upon SCL plus SCS into I test plus this whole value will get multiplied with ID, and value of ID can be write as Gm into VGS. VG we know is the test potential V test, whereas Vs is, we are assuming this potential at Vs only, so it would be Vs divided by SCL plus SCS. So this would be the value of Vs, right? Now I can bring this Vs parameter on the left hand side, so we can take Vs as a common here. So we will get 1 plus Gm upon SCL plus SCS, and this would be equal to IT upon SCL plus SCS plus Gm upon SCL plus SCS into V test. So this would be the value of Vs into this. Now if I bring this parameter and divide here, so I can get the value of Vs, and that would be equal to, so this would be the value of Vs we will get here. So now we have found out the value of Vs. Now we can apply, if you see here, whatever potential Vt is coming here, that is getting divided into two portions. One drop is occurring upon this capacitor and the other one is occurring across this capacitor, right? So I can write it as V test would be equal to V test I can write as Vs plus voltage drop across this capacitor, and that can be write by IT into 1 upon SC. This will be the value of V test. So I have just applied the voltage division rule here. Now we know Vs value we already have calculated. So we need to find Vt divided by IT if you see from the beginning. So what I can write here, V test would be equal to Vs plus IT into SC, right? So Vs we already have here. If I add IT into SC parameter here in this equation, so I can write I test divided by SC parameter, right? This would be equal to V test. So instead of rewriting it again, I have just added the parameter value here so that we can find the exact value. Now if I take common here, IT parameter I can take common. If I take IT as a common, I will get 1 upon SCL plus SCS plus GM plus 1 upon SC. This I will get divided by V test. I can bring this parameter on the left hand side. So if I take V test as a common, I will get, I'm writing it here, V test I'm taking common. So I will get 1 minus GM upon SCL plus SCS plus GM. This is what I will get. Now if you see, we need to find initially V test divided by IT, right? If I bring this parameter here, what I will get, let's try to find that. So I can write it as SC plus SCL plus SCS plus GM divided by, so if I solve it further, I will get this value of V test upon IT. This is the Rin value of this circuit looking from the gate terminal. Further also this can be solved and it can be written in different values of numerator denominator, but this is what we have found out here. So main aim was to understand how to solve these kind of questions where Jadin had to find. These are mostly about the calculation, but initially how we have applied the concept, that was important for this question. If you found this question useful, please share with your friend, and if you haven't subscribed to our channel, please do subscribe. Thank you so much for watching.